Hi, thank you for listening. This paper concerns the effect of attribute alignment on action sequence variability, and we're going to look at evidence from electronic medical records. This is a project, a collaborative project between Michigan State University and the University of Rochester Medical Center. As you can see, Inkyu Kim, myself, Brian Pentland, Julie Ryan Wolf, Yunna, Kenneth Frank, and Alice Pentland have all participated in this research. Um, it's based on support from the National Science Foundation and also from the NIH and the University of Rochester. But of course, the material that you present here do not reflect the views of any of those institutions. It's just our own work. So the question is, what drives the variability of action sequences in clinical work? In theory, tasks are independent of context. It's a long tradition in task design and research on task complexity that argues that we should treat task as separate from context. The task performance should be separate from the task doer. Um, there's a lot of good reasons for that. From that point of view, the content of the work should be the factor that dominates the variability of the work. So different diagnosis, different level of service, different complexity will all lead to different variability in the action sequence. Of course, in practice, we know that context matters a lot, but the question we might ask is what aspect of context is important? Now, Roseman, Recker, and Flender offer a beautiful metaphor for thinking about context as an onion. So the outer layers of the onion are things like, well, for example, the time of year or the country, or these. So in our situation, it would be the organization of the clinic would be an outer thing, something that does not change during the performance of the work. The inner layers of the onion are things that might vary with each action in the performance of a task. So the outer layers tend to be more stable over time than the inner layers, which change constantly. Well, so the punchline to this story is in our study, we discovered that the inner layers of context are very influential. So let's take a look at what we did. So a typical dermatology clinic at the University of Rochester Medical Center, it's a small, simple place like this. And as we move through, you can see there's physicians, licensed practical nurses, clinical techs, residents. And when they're doing the work, there's also a bunch of workstations. The green boxes there indicate the computer workstations. And as they do their work, they're moving around in the clinic all over the place. Julie Ryan Wolf is the person who did this lovely animation. And it just gives you a sense of the clinic's a small place, but there's a lot of things going on. So we extracted electronic medical records from 4 dermatology clinics. We took 2 complete years. We didn't sample anything. We just took all 55,000 patient visits for 2 years in all of their clinics. In the picture there, that's Alice and Julie. So we got about 7.5 million time-stamped records, which indicate the time, of course, the action, the role of the person who took the action, the workstation that they were at when they took the action, the clinic, the diagnosis, and a bunch of other stuff that I didn't put into this table. The point is that we have action, role, and workstation. So we know who did what and where they did it. So we use this information to contribute to calculate a new concept called attribute alignment. Attribute alignment is the number of unique actions, right? Just the action codes divided by the number of unique action attribute n-tuples. So in our case, the action attribute n-tuple includes action, role, and workstation. So it's a 3-tuple actually. So you can think of it this way. If the same actor always does the same action at the same workstation, then attribute alignment will equal 1. That's the idealized case. And in that situation, knowing the action would give you perfect information about the other attributes. Right? If I know who did it, then I know what they did. If I know where they did it, then I know who did it, and so forth. In contrast, though, and in real life, if multiple actors can perform the same action in multiple locations, then attribute alignment is going to tend to be low. And so what this does, attribute alignment gives you a single number that encompasses the diversity of the attributes associated with each action. Right? It gives you a sense of how much variation there is at that innermost layer of the contextual onion. Okay, so that's the key idea here. In our data, we have we used the unique 2 grams to as an indicator of the sequence variety. We have several other variables: the length of the sequence of actions in a visit. A level of service is a thing that they use for billing, so it indicates basically the complexity of the work. We also counted the number of actions in a visit, the number of roles that were involved in a visit, the number of workstations, number of different procedures. So in dermatology, that could be something like freezing a wart or something that they might do to your skin. And then finally, our key variable, the attribute alignment. So these are all calculated at the level of individual visits. So results, it's a lot to sort of absorb, but we counted the number of unique 2 grams per visit as the dependent variable. The length of the sequence, as you might imagine, is the thing that has the biggest effect, has enormous effect on this. So a longer sequence, a longer visit is going to result in more unique 2 grams. But we control for that and control for a bunch of other factors. Just want to call your attention to the attribute alignment, right? So when the attribute alignment is lower, the number of unique 2 grams is bigger. There's more sequence variety when there's more variety in who's doing the work. And if you take a minute to sort of browse through all the other coefficients in this, in fact, the coefficients associated with attribute alignment are larger than anything else except for the length of the sequence itself. So after controlling for the organization of the clinic, after controlling for the number of procedures, after controlling for the number of actions and all that stuff, the attribute alignment has the strongest effect on the sequence variety. So what does that mean? Well, our interpretation of this is that the actions in the event log are really not determined by the action code. If you check meds, right? Check meds by the physician in the exam room is different than check meds by the staff in the front office. Right? If something's being done by a different person or in a different place, it's really a different action. But that doesn't show up if you just look at the actions in the event log. And in terms of Roseman and Recker and Flenders, the inner layer of the onion, this immediate context, really has a big influence. So therefore, what we conclude from this is that the lexicon of actions in the real work in the clinic is much larger than the lexicon of actions in the event log. So the event log is kind of a shadow of what's really going on. By omitting aspects of the immediate context, we're masking, valid signals about the nature of the work. And so this is a theoretical observation. We're, sort of working with this in a variety of ways, but we're quite excited to have a simple way of summarizing this diversity at the level of immediate context, at the level of these sort of attributes of the action, and the effect that has on the work process. So I'd like to, thank you very much for listening, and hopefully you'll have a great conference. Thanks. Bye.